I think it's a natural question is why explore space? And some people have, different people have different views on this. Personally, to my way of thinking, part of human nature is to reach out and explore.
The fact of the matter is, if man stops really stretching himself and extending himself and looking out, then I think that's when civilization will begin to decline. Man just has that inquisitive nature, and it's got to be satisfied.
We're right on the threshold of really a brand new opportunity to explore the solar system and the universe and to increase the value of benefits back here on home.
Skylab itself, as it is presently conceived, will provide us with a capability which grows on Skylab, expands on Skylab, and provides us with an enormous capability to conduct research in space.
And of course, space exploration provides this spiritual quality. It allows you to go to the unknown and find what's there, and hopefully by doing so, you're going to improve your lot.
To have a guy there to change film, to change programs, to repoint the thing, to fix it when it breaks, to take it out and put a new one in, is in many cases not only the rewarding thing to do, but it's the cheap thing to do.
First, we've explored the moon, and we've now going to explore near space, and finally we're going to explore the solar system. All of this, man plays an integral part.
If our children and our children's children are going to enjoy the same quality of life here on Earth as we have enjoyed in the past, we're going to have to learn how to find new resources and how to manage the ones that we have more efficiently and more effectively.
Of course, Apollo went on to take us to the moon, but it also left us with a tremendous technology to look towards the future. And as far as Skylab is concerned, it represents a definite turning point.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition sequence start. All engines running. We have a liftoff.
May 14th, 1973. A working laboratory. Man's first home in space. On its way to Earth orbit. There to be occupied by 3 teams of astronauts in 3 record-breaking missions. Over the next several months, a lot of theory would become fact and give rise to new theory about man, about Earth, about the physical universe. But on this day, a sequence of events began to cast doubt on even a first mission.
Of course, as soon as we could listen in on the flight director net, we realized something had happened to the lab, even though it looked like a perfect launch from where we had been observing it. The meteoroid shield ripped off about 60 seconds into the flight, and with the meteoroid shield gone, this gave us the problem of overheating in the workshop, so many different ideas in the intervening 10 days were put out as different means of being able to rig a temporary heat shield or a permanent heat shield which would allow us to salvage the vehicle.
Of course, all the NASA centers were working on it, all our contractors were working on it, and taking an active part in the discussions and the decisions that were made as to what's wrong with the workshop and how we're going to fix it. We went to Marshall to work in the water tank with the proposed fixes, talked to the engineers who were working on it, talked to the flight planners, and discussed it, of course, with management. And we actually launched on the 25th of May with 3 potential ways of covering the workshop to shade it from the sun.
About 7.5 hours after liftoff, as we were rendezvousing with the workshop, the extent of the damage became apparent to us very rapidly. We first confirmed that the one solar wing had completely left the vehicle and was no longer around. We could see the damaged wires at the hinge line. And of course, all the gold foil which normally would have been underneath the heat shield and meteoroid shield, was exposed to the sunlight, and it had darkened on the sun side considerably. Then as we got around to the side where the jammed solar wing was, it became immediately obvious to us that this little tiny metal strap that had torn off the heat shield and meteoroid shield had jammed the solar wing.
Well, the advantages which manned spaceflight offers are in the area of repair and maintenance, which we've demonstrated time and time again on Skylab. As a matter of fact, the whole Skylab series of flights would have been a failure had it not been for the ability of the first crew to repair the space station.
Pete and I went down into the workshop, installed the canister that contained the parasol in the scientific airlock. Joe was observing the deployment of the parasol from the command module.
I couldn't see the airlock itself, but I could see this funny-looking orange thing, all rolled up and skinny, come pooching out of there. And then Pete said, "Okay, we're going to let her go," and it just started to unfold and did a lot of flopping, and it kind of settled halfway folded and halfway unfolded.
We deployed it as best we could, pulled it back down to us about a foot off, and that was it. It worked quite well for the rest of the mission. I think on about day 4 or 5, we definitely knew that it was no longer an uncomfortable environment. It was warm, but certainly nothing that you couldn't put up with.
Skylab, we're reading you loud and clear over the Vanguard for 8 minutes.
Of course, not having gotten the wing out on our first attempt when we came up there, we really had about half of the electrical capability that we should have had. So it was very, very important to attempt to get that jammed solar panel out.
I think we probably wouldn't have had any Skylab missions had it not been for the fact that man was able to get to the Skylab and to make it habitable and to repair it in such a way that all of the missions were completely successful.
So Joe tried, and then we decided to tighten it up again, and I'd try, and I got under it, and boy, it broke. It let go in one big hurry, and there I was, launched into space again, free-floating, hanging on the end of this string. And, well, by the time I got straightened out again and looked around, why, there it was, out and deployed.
Thus, very early, man's presence proved to be vital. It would be so in the missions that followed.
At the proper time. But in areas where you need man's flexibility and his initiative, for instance, in the deployment of the solar wing on the first manned mission, and on the deployment of the sail that was used to provide thermal shading for the workshop on the second mission, and on our mission where we had to resurface the coolant system, or where we had to actually get out and unjam or move the filter wheel in the solar telescope cameras. That's where you need man. You need man up there when you need some freewheeling judgment. And the tasks in space that should be assigned to man are the tasks that require him to use his mind and his abilities, his unique abilities, which certainly can't be covered by programming a computer.
The reason for having a complete package of medical experiments on Skylab, as opposed to the case in the earlier missions where we did our medical stuff primarily before flight and then after flight, was that we were going to fly much longer than we ever